Hey everybody, just wanted to answer a bunch of questions that people may have about the final project because that's a big part of the grade. And um, let's just go right at it. So if you want to find out more about it, you go to Learning Units and then Final Project and Presentation here, and then click right here. This is last year's rubric, but it's probably not going to change much for this year. Okay. Now, remember that the final project, the whole point is to put everything together that you learned and put it in one project, and then you show that off. In fact, this should be something really cool that that you're really proud of, because you may someday want to use it to show someone what you can do as part of an interview or something like that. I do know that some students have been able to get jobs because of the work that they did right here for this project. So um, I'm going to stick very close to this rubric. And so if you can do all of these things, you should be able to just nail it, you know? So you should see the points on the left here, and then you see what you need to be able to do. Fully defined, well-relationed, complex sketches for the 2D cross sections. Okay, so not just a square or a circle, but stuff more like the handle from the saw, or the handle from the screwdriver, or the handle from or maybe the top of the crescent wrench. Any of those kinds of things are going to be on that same level of what I call fully defined, of course, well relationed, using relations rather than like everything dimension, and complex sketches. Okay, so then make sure that your project has at least 6 parts. Now I want you to come and talk to me about your project. So far I've got a few students who have done that, and I've given them some advice and so on. Some things are are a lot more complicated than you think they are, and some things are a lot simpler than you think they might be. So my rule has always been not anything that you find in the classroom, because I want to make sure you look outside the classroom. Well, we're not in the classroom today, but that still applies. I don't want you to, just whatever happens to be available, your phone, your mouse. In fact, I would tell you, you're supposed to take it apart. So if you want to do your phone, you're going to have to take it apart and do every single part that's inside. Okay, so now you're not doing your phone. Good. All right. So let's look at the other things. And if you want someone to take your phone apart, I do know people who can do that. So you probably don't want to have that happen, because putting it back together is really the hard part. So of those 6 parts, at least 2 must be fairly complex. Okay. And if you've got just a dowel, or just a something really, really, really simple like that, it doesn't even count as one of the parts. But a rivet would count as a part, maybe not terribly complex, but one of those handles, for example, might be fairly complex. And then you're supposed to model it using an efficient, in other words, not just like 14 bazillion things. You should know how to use it efficiently. So you can do a lot of things with just protrusions and cuts, but do, what if you could use just one feature that could do a whole bunch of those different things? Then that means you know what you're doing. You're also maintaining design intent. So efficient and balanced variety. So if you just used one thing over and over again, that's not balanced. So let's look at the feature types used. So there are all these different, I think I have 15 here, something like that. I'm sure that there are others that you can use that you'd be interested. Go ahead, use those. I'll write those down. I'll note them. Do you have to use all of them? No, you do not have to use all of them. You should use what you need, what makes sense. But you can use a loft to do some really cool things that just some of these won't work. But maybe a revolve section will do the same thing, just differently. I don't know. But whatever you do, try to use a variety of these different things that can work. So if you've got something that has a pattern, then by all means, try to use a linear or circular pattern, whatever works for it, okay? Now, there might be some times when you might want to say, you know what, I could use a chamfer, but instead I'm going to use a draft. Well, there might be a good reason to use one over the other. But if you've already done a bunch of chamfers, sure, go ahead and use the draft just to show off what you can do. But by and large, you should be just doing what needs to be efficient, what makes the most sense and uses that captures your design intent. All right. So that's a bunch of points right there. One of those parts must involve a design table that uses formulas. So if you haven't done the design table stuff and you haven't used the spreadsheet stuff yet, make sure you get that done so that this is not a difficult part. It's worth 10% of the whole final project. Okay. So that's a big chunk that a lot of people just leave sitting on the table. So make sure that you learn how to do that design table stuff and then apply it to just one of the parts in your um, in your project. Okay, so again, back to capturing design intent. Okay, here's where kind of like, okay, you can do a whole bunch of stuff, but it can maybe it's just kind of thrown together and kind of janky, and you're just like, well, it kind of looks okay, kind of thing. But if I can't change critical dimensions with relative ease, so what if I had created that screwdriver, and if I change the length of the square shaft, the whole thing should change perfectly and beautifully, right? And that's the way I designed it. But if I couldn't do that, if I just changed that dimension and it all broke and bad things happened and yelled at me, it was all yellow or red or errors, but then that's not really capturing design intent. So I should be able to make it longer, shorter, wider, narrower, more open, more closed, whatever, in various key uh, dimensions. Okay, I'm not talking necessarily a fillet, because fillets can break pretty easily, but some of the bigger things that you could say, if I were to make a family of these parts, would I want them to be longer, shorter, or deeper, or what? Thicker, thinner? Uh, Make sure that those things can be changed, not for any value, but within a reasonable 10, 20, 30, 40, 50% range. Okay. All right. Next step, another place where students leave uh, points right on the table. Create well-defined drawings. Showing you how to do drawings. We did one for the rivet. We did assembly drawings um, for the screwdriver. I want to make sure that you know how to basically set up 2D drawings, one for each of the two complex parts, and an assembly drawing for the main assembly. So that's 3 drawings. So you got 6 parts, 3 drawings, and then you're to assemble the parts using at least one subassembly and one top assembly, like we did for a screwdriver. All right. So the screwdriver had the top assembly and then also the shaft as a subassembly. So make sure that you can show that you can create a subassembly and then put it into a bigger assembly. That's what that part's about. Okay. Now we get to the presentation. When we have our last day of class, or whatever it is, it's going to be, I believe, quote unquote class, we're going to have a time where a bunch of us are together on Zoom, and y'all are going to uh, show your assignments. It's going to be about 10 or 15 minutes per team. Okay. So if you do get together as a team, or assuming that you're together as a team, uh, you can show the various parts together and the various things, and you're going to show it off. You're going to say, hey, look what we did here, look what we did there. And that's going to be kind of a neat thing, hopefully, for you to do. And it's going to be done over Zoom. um, and why do I do it over, as a team fashion, even over Zoom? Well, guess what? That's reality. I've had to work before and after the pandemic. I've had to work with clients and other people that I've worked with, other colleagues, uh, at a distance, and we exchange. We talk on the phone. We exchange files. I make videos, that kind of stuff. So, if you have this skill that you can work in a team over a distance, that's a great skill to have, and it's going to be valuable. Okay, so what happens if you are like, hey, cool, I learned how to do multi-point surface. Oh, that's really cool. That's great. But the thing is, this is an introductory course, and I want to know, can you do the basics? If you can't do the basics, then it's hard to say, hey, that you did well in this class. So make sure you get the basics down. Once you have this stuff down, look, 10 points here. A lot of times students leave this 10 points just sitting there, and they do it because they want to do something really cool. Well, you can do that maybe some other time. Look, 5 points for really cool stuff. I love it when you do cool stuff. Don't get me wrong. I'm going to show you some neat things, but it's not that's not the point of this course, and that's not the point of this particular exercise. So subtractions. Extra, unused, unnecessary features and sketches. You know that I will call you back. I'll make you delete those things. So make sure you don't have anything that you're not using in your models. Disorganized feature structure. If it looks like it got cobbled together, then maybe you might want to redo it or reorganize the features, because that's an important part of design intent. Undefined sketches or open loop, or that um, other kind of the selected contour error, we don't want those. That'll end up in subtractions. If you cheated or plagiarized, I had a student once that copied exactly somebody else's project off the internet. I looked it up as he was doing it because I knew he hadn't done it. It was pretty it was quite pathetic. It was pretty bad. So don't do that. Just don't even bother showing up if that's what you're going to do. But if I find out that you weren't carrying your weight in your team, you might get some subtractions. If you don't show up, or if you're late, that's it. Also, you're expected to go and see other people's presentations, because you're going to learn from them and they're going to learn from you. So that's part and parcel of the presentations. All right, now you're like, well, thanks for talking to me all about this, and thanks for the rubric. Do you have any examples? And the answer to that is yes, I do. All right. So, I was out here working on the two something else. Okay. So let's go here. I had these organized. Okay. Is this going to kick in? All right. It's taken a couple of seconds, but all right. So I went back a few years and I grabbed some examples of, a couple really good ones and one so-so project. And hopefully this is going to come up. Maybe we'll just hit pause on this until it does. Okay, so we're back and we're looking at this gentleman's project, and this was a really, really nice one. Okay, this is probably the best one of that particular year. Hard to know exactly, but he and his partner, okay, I'll tell you, it was two of them. They worked together on this, and look at all the. Okay, so they've got. You think, oh, there's only 3 parts? No, these are some sub-assemblies here with a whole bunch of other parts, and they just went to town on this. So you can see that they have can opener, not a bottle opener, sorry, and screwdriver and main blade and punch and these. Now watch also what they did here with this. They had a limit, I believe, a limit on this. So I can't drag it any further. So they used a pretty cool limit mate on it, probably right down here. Yeah, there it is, limit angle on that. And we can move this back and forth, I think. Wait, maybe it's this one. Okay, well, they had some kind of setup here where these things would open up. I can't remember how it worked. Okay, maybe it's just a, oh yeah, they made configurations And I guess it's going to take a while for it to do. So anyway, obviously this is way more than 6 parts. Do you need to do something like this to get an A? No, but it certainly helps. And like I said, if they didn't make their drawings, guess what? The best they could do here would be a 90 if they didn't do something with uh, a with a design table. The best they could have done would have been an 80. So, and I hold straight to that. So make sure that you take care of the basics and then do all the cool fun things. Okay, so we've got pliers here. All right, I'm not quite sure how they had this set up, but they did have it so that you could open it up and close it up in various sundry ways. Look at the detail they have on making these numbers and the ruler on that. Pretty neat. Uh, all right, well, I don't know how they operated it, but it was really cool. Okay, so there's that, and let's make sure that goes down like that. And I will go to, see if I can find this. Wow, this is really slow. Okay, so here is one of the drawings that they made of one of those jaws, and the plier. Again, it didn't have to be super duper crazy, but they did put in a good number of these, and they showed how they could make a decent drawing out. Is this an actually? Could you actually make this part using this drawing? No, but you'd be on your way, and you'd have to do some modifications. But they did a fairly decent job here. All right, what's next? Um, all right, here's also the drawing for that particular project here, but this is the assembly, and he's got a bill of materials on here and everything, maybe not a title, but they certainly did a great job on the modeling and a decent job on the drawings. So let's see what's next. Let's go to a different example here. Okay, the student actually he actually makes knives, and now it's not doing what I want it to do. Yeah, tried pulling them all up. Okay, so here is this really nice setup here um, of this particular knife. Now notice that little thing here. Notice how this piece is actually bent slightly from the rest of the knife here. This is done using a really interesting feature that he learned on its own, and he got a few extra points for that. But here is uh, the knife, and if you'll notice, it has a number of good, but not a lot. They've got a uh, handful of parts. And here's a subassembly. Here's another subassembly. Let's go check out this part here. Hopefully, hopefully. Yeah, I do not know why this is so slow. I mean, I have my thoughts, but there we go. Okay, so here is this part. Notice how he's got bosses, patterns, cuts, a counter bore, fillets, and this cool flex thing here. So this was one of his more complicated parts, and he used these very effectively, very efficiently. And then there's that neat little flex thing that just comes over here. So if we take this up like this, that's how it started. And then he was able to create this flex using this plane and a few other things. It was really well done. But again, even though it's brand new learning something I don't cover in class, I don't I have to look up how to do that one. It's not worth nearly as much as some of the other things. Okay, so let's go back to that. Nope. We want to go back to this here. I must be overloading this thing, but I don't think I am. Sorry it's taking so long, folks. All right. So another thing he did, he made these open and close the right where they're supposed to be, using that same limit angle kind of thing. All right, and let's go to one of his drawings. Okay, so here is his assembly drawing, and notice how he has everything nicely ballooned out here and associated with a good bill of materials. I mean, I would do it a little bit differently because he's got these balloons way over here instead of closer to where they're pointing. But he's got some basic dimensions on here and a nice detail of what's going on. So good enough job there. And he also made a knife blade drawing as well. Not sure why those are purple right off the bat. It means something changed, I believe. But at the moment, I'm not going to worry about it. And so he made another detailed drawing of a particular part. Okay, so let's go to another one here. Bolt cutters. Now this one is a very complex one as well. But he did reuse a number of the parts. So it's not that many parts, and it looks more complicated than it actually is. He just did a really nice, clean job on this. All right. So yeah, he's got a lot of parts here, but some of them are, like all these hinges and stuff like that are pretty simple, and they're repeated. So if you see, let's see if we can move this. Oh yeah, see they move too. That's pretty cool. That's dang cool. I like that. They've got, go here, open that one up. Hopefully it'll open up. Yep, shouldn't take this long. Your mileage may vary. Okay, so for this part, all he had were cut extrudes and boss extrudes with a mirror, but also a hole and a fillet or two. So, but he effectively used them. He used mirroring and so on to make a difference here. Okay, he may have been able to do some things a little bit more efficiently, but still worked out pretty well. Trying to get back to that. Oof. I am so sorry this is taking so long. It wasn't taking long before. All right, and I'm gonna look at this. Something similar, just boss extrude, but he had to make an extra plane there and cut, and then he used a draft and mirrored that same draft. All right, so here's one that's a little bit simpler. Okay, it's simpler, but he still has a number of these parts. 1, 2, 3, 4, 5, 6, something like that parts. And you take this off, and there you have a pizza cutter. Not bad. All right. So for this, did he use, let's see what he used on that. He used sheet metal. So that was something a little bit different. So he was able to use something new, get some points for that, if you will. The arm here used more sheet metal, so that was kind of cool. He liked doing that. The handle, I guess it's just a revolve fillet, but he also used a shell because he said it was injection molded. So that's great. So notice how it might be simple, but he's using a variety of features to achieve what needs to be done and in the right way as well. So what's this? This is the cover, and he used basic Boss bases, but since it's a plastic part, he advisedly used a shell and a bunch of fillets and a cut on the mirror. So again, simple, but effective. All right. And let me see if there's another example here. I want to definitely get to, all right, Brad's. Now, Brad, interestingly enough, is now using these skills almost full time. He knows a lot about SolidWorks that he never picked up in class. Like most of what he knows about SolidWorks, he learned on the job. But because of SolidWorks, he was able to get the job he has now. And it's nice being in touch with him. So he simply used, he was on his own team, I guess. So all he had were 3 parts. And not saying that this was an amazing project, but it's something that got him through. And notice how he did use boss, cut, sketch, but a circular pattern along here. And then he used boss, cut, plane, loft, sketch, a revolve, a helix, and a cut sweep on this part. Is another screw similar to what we used for that set screw that we had before. Oh, this is the other part, which was, oh, it was just a boss extrude and a shell. I guess that's coming up now. I hope it's coming up now. Here we go. Yep, so all it used was a boss extrude, and then there's a little bit of an indent up here, so he thought it would be best to use a shell for that. So maybe he was right. I can't remember, but there you go. And I wanted to just open this one up here so you could see it a little bit better. All right, so this is similar to some of the work we did, but he used hex and circle or extrusion here, but then this cut sweep. So he extended this out first. Okay, so he made all of this with a revolve, just like we did with the with several of the different parts. We had the handle of the one, and we used a revolve for the rivet, the very first part there. And so he used this revolve here, that sketch right there. Okay. So anyway, again, use a variety of different things. Did he have to use a loft right here? Nah, he didn't really have to use a loft, but he just wanted to show off that he could in that particular instance, and it worked because it worked for that particular geometry. So, all right, well, that was a little bit too long, but I hope that this gave you a lot of ideas on what is required and what has been done in the past to achieve the same objectives. So let me know if you have any other additional questions, and I hope to answer them. Thanks.